tomorrow will be better. 0.5 kg of a metal block at 100 degrees Celsius is placed in 1 kg of water at 20 degrees Celsius. Their final temperature is 24 degrees Celsius. Find the heat lost by the metal and hence its specific heat capacity. Follow me, dear friends. Solution. Let's understand what's happening here. The moment this hot piece of metal is dipped into the water, the hot piece of metal will give off some heat. And according to the law of calorimetry, all of the heat which this piece of metal gives off is totally absorbed by the water. And of course, the water will increase its temperature while the temperature of the piece of metal is going to drop. So, in other words, this is what we are saying. The total heat loss by the block of metal will be the total heat gained by water. So, let's remind ourselves of the important expression for heat loss or heat gain. We know that Q equals mc delta theta, where m is a mass, this is a heat specific capacity, and then this is a change in temperature. Now, in the case of the water, the change in temperature will be equal to, let's calculate it first in degrees Celsius. We will have the final temperature, 24 degrees Celsius, minus initial temperature, 20 degrees Celsius. This gives us 4 degrees Celsius. Dear friends, the change in temperature, I'm talking of just the change in temperature, in this case, which is 4 degrees, is also the same as 4 Kelvin. Follow me more for an explanation on this. It means that the water, the amount of heat gained by the water will be equal to the mass of the water, 1 kg, times specific heat capacity of the water, which we are expected to know, 4,200, and then finally times the change in temperature, which is 4. If you correctly punch this, we should have 16,800 joules because it's an energy. Therefore, this is the same heat which is lost by the piece of metal. One question already answered. Hence, find the specific heat capacity of the piece of metal. But we have to remind ourselves of the formula to obtain this. We will say, but Q lost by the metal is also given by mc change in temperature. But for the fact that in this case, this change in temperature here is not the same change in temperature with the water. So change in temperature for the metal is going to be equal to its initial temperature, 100 degrees Celsius, minus its final temperature, which is this. And this will give us 76 degrees Celsius, which, like I said earlier, will be the same in Kelvin. At this point, let us make C the subject of the formula here. This